All right, let's look at the complex numbers. All right, so let's start with the motivation. All right, let's say we want to solve this following quadratic equation. Z squared plus z plus 1 is equal to 0. All right, and since I don't think we can factor out cleanly, so I'm gonna go ahead and use the quadratic formula. Right, so if you forget, the quadratic formula goes, if you have a quadratic equation, ax squared plus bx plus c equal to 0, then x can be found by negative b plus or minus square root of b squared minus 4ac over 2a. Alright, so let's go through that. Alright, so in this case, the coefficient is, let's see, a is going to be 1. And also b is going to be 1 as well, and the c is 1. Alright, going through the quadratic formula, z value, z is going to be equal to negative 1 plus or minus square root of 1 squared minus 4a is 1, c is 1 over 2a, which is 1. Alright, so if you clean it up, you can see that you have a negative 1 plus or minus square root of 1 minus 4, so it's negative 3, and over 2 times 1 is 2. Right? So immediately we notice that there's a problem, right? So here, in a real number system, we cannot have a negative value inside the square root. So this is going to be, this is not going to be a real number, right? So we need to introduce a new kind of number so that we can somewhat make sense out of this expression. Alright, so we introduce thing called I, which has sort of an impossible property that when you square this guy, you get negative 1. Right, so that we can write this guy as, right, so first part is negative 1/2, so you have negative 1/2, so there's no problem there, right, plus or minus, right. So another way to write that would be I would be square root of negative 1. Alright, so if you see that there's a square root of negative 1, so square root of 3, so it's going to be square root of 3, then I, oh actually there's over 2 there. Alright, so this is the expression we get out of quadratic formula, and we kind of introduce a symbol called I, right, whose property is I squared equals negative 1. Alright, so we can get this expression, and just a name, and this number without I here is called the real part. Alright, and notation is a real part, so real part of z, right? And here, the number in front of coefficient of I is called the imaginary part. So imaginary part. And its notation is Im, imaginary, of z. Alright, so this kind of strange expression, it can be expressed as a pair of real numbers. Imaginary part is a real number, and the real part is also a real number. Alright, so we can come up with the set of complex numbers, which are written this way. So this is a notation, right? Then we're going to collect all expressions in the form of a plus bi, right? Then where A and B are real numbers, right? So it's each complex number can be expressed as a pair of real numbers, real part and imaginary part, right? So that's the set of complex numbers, and you can see that since each number or complex number can be expressed as a pair of real numbers, which remind us of a point in XY coordinate plane, right? So it's a good way to visualize complex numbers using sort of the XY plane. It's called the complex plane. That will be the next topic. All right, that's it. I hope that this was clear.